Okay, for the first time in my life, not that I've been on stage many times, but I am relieved to be on stage because I almost didn't make it here. Usually I'm just stressed out. Now I'm actually relieved. It's pretty cool. So I am going to talk to you about rendering Blender scenes on Lambda and how we got there. This is the agenda, so I'll say a few words about myself, about what is Blender, because this is really, you're not the typical crowd that would know what Blender is. What were we trying to do? What were the options that we considered? How did we finally make it? And then I'll share a few opening thoughts about actually rendering in the cloud in general. And when I say in the cloud, I'm going to be very AWS specific, actually. But first, to cheer you up, there's a picture of my child. He was helping me lay out my introduction slide. So my name is JR. It's short for Jean-Rémi. You can call me either or, I don't mind. I'm French. I live in New York. I am part of the AWS Community Builders group. If you are into writing content and trying out new things in the cloud, it's a fairly easy program to get on. And AWS, among many things, give you support, access to other like-minded people, and also some free credits to play with. So it's always nice. I work for a company called Theodo. So we're about 500 people software consultancy based out of Paris in France, London in the UK, and New York. We also have, we have hired one colleague in Huntsville. So we are also an Alabama-based company as of like a few months ago, and that feels pretty cool. He's going to join me later today. We're an AWS consulting partner, so this explains in part why everything I'm going to talk about today is on AWS. We also work with other cloud providers and on-prem for different clients. When I say software consultancy, we build things. Initially, the company was created 12 years ago, and we were a PHP dev shop. PHP was hugely popular in France, and we diversified over the many years, well, the 12 years since. Cool, so what is Blender? Blender is a very cool piece of software created by this guy here called Ton Roosendaal. He is from the Netherlands. The first release was released in 1994, and he built it himself as part of his company. So at the time, it was a private company. They went through a super interesting story since 1994. And which led them to become open source in 2002. The short story is he needed to raise funds. He was building a very interesting tool that a lot of could benefit many industries. So Blender was proprietary at the time. So raised a lot of funds. The dot-com bubble happened. The company went bust. He had to buy back the source code for a few $100,000 from the previous company. And as soon as he got it, he open sourced it, created the Blender Foundation, and now Blender is the leading open source software to create content in 3D. And when I say create content, it's like many things. I'll dig into that. So the stats for 2020 are 14 million downloads. From their own website. You can also download it from other places, and they don't really track who's using it, so it's a vague metric, but it's huge. The project is now supported by many large companies who build very interesting things with them that you would not really suspect. And I'm not going to dig into that too much, but I'm actually going to give you an example of what you can build with it. So this is Blender. So I guess to a 3D artist, it just looks like the AWS console to a software engineer. It's really very scary. You see at the top, there's like a bunch of small, can I do this? Yeah, small tabs. each tab is like a world of its own. Like, so you can lay out 3D models, you can create new 3D models, you can sculpt them like they were clay, you can do texturing, animation, shading, you can code shaders, and you can render, you can edit videos, you can do 2D animation as well as 3D animation. There used to be a feature that was a game engine, so you could export your own game, like really huge piece of software. They decommissioned the game engine. Everything is left still. The key part here is that almost everything you can do as a human being clicking through the UI, you can actually do it as a software engineer coding your nice little Python API, like Python script. So that's extremely helpful in any company's workflow, any company that leverages 3D, even if your designers don't use Blender itself to like create new models or new scenes. At some point, if you see that part of their process could be improved, that there's a lot of manual tasks, it's likely that you can maybe import those files into Blender, automate the hell out of it, and then render it or export it back into something else. So it's a really, really great toolbox for us like software engineers or anyone who has like identified that there are process improvements at their company. And like I said, like actually more and more companies use 3D. Like so I was at DevOps Days rally a couple of days ago, and someone who works in the financial industry told me, "Oh yeah, my marketing team, they use Blender for I don't know what." So I think everyone is starting to use it. So what were we doing? So the guy is not taking a selfie. I'm sorry, it is the selfie emoji. But he's not taking a selfie. So one of our clients is in the apparel industry, and they have teams all around the world, but mostly in Asia, who source new materials for, let's say, I'm going to simplify and say dresses. So they source new materials, they walk around like all year, and they find some like cool piece of cloth, and they're gonna scan it, not with their phones, I'm simplifying it. They scan the material with like super high fidelity scanning that gives us a lot of properties, like physical properties of how the material behaves when lights come on it and how it reflects it, etc. Yeah. So they scan those materials, and then there's another team somewhere else, the designers, and they want to make new dresses, and they want their dresses to be trendy, gold or blue, or what was the joke? I think, is the dress blue or this one's blue, I think. So they want to make new dresses with those new materials, and they want to try out things. So one thing we at Theodo that we built for them is actually the app that the designers use. It's a simplified app. It's not Blender. It's something else that they can use to like look at a model of a dress that someone else modeled, and this person, this designer, is really specifically a fabric designer, you could call them. They pick and choose from a list of thumbnails, or they wanted to pick and choose from a list of thumbnails that are fresh off the scan somewhere else in the world. Say, hey, this part is going to be in this shiny leather that we just found, but the top is going to be silk, and how about like, I don't know, wool for the bottom. So this is what they wanted to do. So they came to us, they said, okay, you build this thing for us now, we have these guys around the world like taking pictures of new materials. How could we connect the dots, knowing that for our designers, what's important at that stage is that they have a small preview of each new material, and we'd like to standardize it to like, let's say a small thumbnail of what the scan gives when you, let's say you simulate a small piece of cloth that's like falling elegantly off the edge of this table. Like, so for each material that they scan, we're going to generate a small thumbnail that they're all in the same situation, so it's comparable. You're going to understand like, okay, how the light shines on the edge. If it's silk or if it's wool, it's not going to shine at all, etc. So we're like, okay, cool, let's think about it. We should probably use Blender, load the material that we got from these guys around the world, load them into a scene, somehow render that scene store the output, a simple like PNG, and then inside the software that the designers use, we just load all the PNGs that are available. So the big question was, okay, how do we do this thing where right here, how do we do this? How do we render Blender scenes in the cloud? So at Theodo, we love serverless because we like to not think about updates so much or scaling, etc. So we considered 4 options from the server most to the server least. I added trademarks, but it's absolutely not trademarks, it's just for the fun. So we had 4 options, and there's going to be a bit of like AWS jargon. Again, I'm sorry, but I'm going to try to not be too jargony for those who don't use AWS. So option 1 was using an EC2 instance, so like the basic virtual machine at AWS, and either have it run all the time, and whenever there's a new job to render, we send it to this machine, and it renders it, and we're done. We could even configure it to actually shut down, maybe at night when there's no new materials coming in, or spin it up on demand. It just takes a couple minutes to spin up the instance, but maybe that's an option. Option 2 was, hey, there's a product that's called EC2 Spot instances, and they're just cheaper. They're like unused resources at any point in time that AWS is like giving you for like a huge discount. So that could be a good way to keep the cost down. Option 3 is Fargate, so it's a way to run containers very easily on AWS. And the last way was Lambda. And this is what we picked, but let's not spoil it too much. Well, it's in the title. So the first thing we considered when we wanted to pick is actually, there are 2 big categories in the 4 resources I showed you. Some are GPU enabled, others are not. So we did a quick study. So the cheapest GPU-enabled instance you can get at Amazon is called G4DN X-Large. It comes with 1 NVIDIA GPU and 4 vCPUs. And so we ran this quick little experiment. So here on the left, you see this like demo scene. Blender comes with a ton of demo files. This one is kind of like the traditional one that everybody uses. So this is a render from that demo scene, 500 pixels wide. If you use on that instance, if you just use the CPU to render with Blender, it takes 103 seconds. If you use the GPU on that same machine, it takes 11 seconds. So if you break down the cost, like the actual runtime cost of that instance, it will cost you like 1.5 cents with the CPU and 0.16 cents with the GPU. So you're like, wow, yeah, rendering with the GPU is really attractive. It's much more efficient, it's faster, it's cheaper. So it looked like a very good candidate. But like I said, we also considered more container-based solutions. So the 2 are Fargate and Lambda. So one thing you may need to know is that AWS Lambda initially was created to, like, you write some code, you put your code on AWS and you tell AWS, hey, can you run this code whenever I need it? And then they released a new feature. Instead of saying run this code, you can say run this container. So it's an extremely easy way to spin up a container, use it, and destroy it. It's gone. Spins up in like a few 100 milliseconds, very fast. Another important point is that you can run Blender in a container. Like there's actually the easiest way is to check out the New York Times R&D GitHub. They maintain a great like Blender Ubuntu container image. So very easily you can experiment, and I'll share resources to do that later. You can spin up Blender in a container. So we're like, okay, we could run it either on Fargate or on Lambda. Fargate has a CPU limitation, you can only have 4, and Lambda, kind of surprisingly, is actually more powerful than Fargate. You can have up to 6 CPUs. So we did that same test, same scene, we ran it on a Lambda with 6 vCPUs, and it cost us 0.85 cents. So we're like, okay, interesting. What do we decide from this? So we decided that we would not use EC2 spot instances because actually there's a big restriction on them. You cannot use GPU-enabled spot instances. So okay, we have only 3 options to go. We decided to also discard Fargate because there's also no GPU. Lambda also doesn't have GPU, but Fargate has fewer vCPUs than Lambda, so then why would we use it? So we only had 2 options left, EC2 and Lambda, and I'm going to talk about the pros and cons of each. So like I mentioned, EC2 gives you GPUs. You can have several GPUs attached to your instance. It can be extremely powerful, can run all the time. So if you have a lot of work that comes in, you can have it running all the time and just working through the backlog constantly. And the cost per render was actually very cheap when leveraging the GPU. Also, there's one very important thing in the world of 3D is that sometimes you need a lot of memory, really a lot of memory to load very complex scenes. So on an EC2 instance, you're basically unlimited RAM and render time. If the render time takes a week, it's fine. The instance is going to run for a week. On the other end, we have Lambda. It's super easy to scale. You just don't even have to think about scaling. So if you have big spikes of jobs to render, they're just going to spin up as many as you need, up to a certain limit. It's very easy to maintain. All we have to think about is, okay, there is this container image, and if we change it, next time we spin it up, it's going to be the new one. We don't have to update the underlying OS, etc. And the startup times of the Lambda functions with this very heavy Blender container image is just 1 second. So it's very, very quick. For EC2, there is a maintenance cost. Like you have to update your OS, you have to update Blender, you have to, yeah. So it's some work, you have to think about it. It's harder to set up. And the fun fact is that we also use EC2s with GPUs for other workloads that we do. And one thing we run into is that every so often, when we need one, AWS says, hey, actually, no, sorry, we just ran out of EC2s with GPUs. Like, is anyone mining Bitcoin on AWS? I don't know, but that they take it away from us. So there is a shortage of GPUs. That might not be the case anymore in a couple of months. Who knows? But today, if you were going to do this, there's definitely something to consider. If you manage to grab one of these EC2s, you're going to want to keep it running all the time. Because you don't want to be stuck like, oh, I need to render something, but no, it's gone. So it means like the cost impact is actually huge. It's going to cost you a lot of money to keep it running all the time. If you don't make any use of it, it's a big, big waste. Lambda, on the other hand, doesn't have a GPU. If you need more than 10 gigabytes of RAM to load your scenes, it's just impossible. And your render cannot take more than 15 minutes. Like any Lambda function is going to shut down after 15 minutes, whatever you do. So this means that actually, even though Lambda is a simple solution, if you need more than 15 minutes of rendering, you need to come up with like additional complexity. And the whole point of using Lambda is to not be complex. But you could think of, okay, if my scene needs like 20 minutes to render, then maybe I can like cut it in half and have one Lambda render one part and another Lambda render the other part, and then it just takes 10 minutes. So that works, but it's more code, more infrastructure to maintain, etc. So it kind of like destroys all the advantages you had previously. So why we picked Lambda is really because of this. This is the typical day of our Lambda functions, of our let's call it serverless render farm. Every once in a while, we get a new or a couple of new materials that are uploaded to our just let's say S3 bucket, and so we just like spin up as many lambdas as we need near instantly. They render the scene. Our scene is fairly simple. Like I said, it's just like a small piece of cloth that's simulated, that's hanging on the corner of a table. So it's pretty fast. It takes about a minute to a minute and a half, depending on the material. So we just spin up as many as we need. And when they're done, we don't pay for anything, nothing happens. We can update our version of Blender or whatever. And next time we need it, they just spin up. So for us, this is really why we did it. In the end, the cost per render is fairly high. It's like 0.85 cents. So if you have like thousands and thousands, it's starting to show up. But for the size of our clients, it's not an issue. But it's more expensive than if we had rendered it on a GPU. If we had like, let's say, a social media app where people constantly are adding new things, and you're starting to see like social apps where you can give 3 words, and then there's a machine learning algorithm that gives you a picture that they came up based on the 3 words. If you have thousands of people doing this constantly, then definitely that's a scenario where you're going to want to have like a bunch of EC2s working through the backlog and probably having a queue to like as a buffer, and then there's going to be a wait time for the end users, but you're going to have 100% load constantly on your machines, so you're going to get the most of the money you pay, and your unit cost is going to be low. If like us, every now and then you have someone who needs something, you don't want to pay for it, and have someone, an instance like sitting and doing nothing all the time. So now how we built it. So who's, maybe a quick show of hands, like who's familiar with the serverless framework? Quite a few of you, nice. Okay, cool. But first, the Dockerfile. So this is like I said, there's this cool image that the New York Times is maintaining, where it's just like Ubuntu with everything it needs to run Blender. And it comes in 2 flavors, GPU enabled or CPU enabled. And then just a bunch of like, and some like scaffolding so that the Dockerfile is understood by AWS Lambda. You cannot just take any container and throw it at AWS Lambda. You need to make a few changes so that it's compatible with the Lambda API. So this is called AWS Lambda RIC, there you go. And then entry point, same thing, and the classic, like the Apphandler is what is going to be executed when an event is brought in by Lambda. Our serverless framework file, so it's not super readable. If you just Google serverless Blender, for now, it's your top result. You can read all of this. But I'll quickly walk you through it. So the serverless framework is really super helpful for this. We just said, okay, here is my image. Here is a bucket where you're gonna get this, the materials and the scene from. Here is and also where you're gonna upload the renders when they're done. And this is the function to run when you're invoked. So this is our handler. The handler basically does nothing but call the Blender Python API and with a script. So here you just like say, hey Blender, spin up in the background and take this script and do whatever it says in the script. And so this is the script. It's well documented. You can do, like I said, like many things with it. In our case, we just like we get the bucket, we create a file name for our little thumbnail we're going to render, and then we say, okay, set the resolution of the picture. Where do I open the scene file? Where do I save the render? And at the end, okay, just upload the render, and we're done. That was it. So super simple. We don't need to think about much really, and it did the job really well. So now opening thoughts. The many ways you can run Blender in the cloud. So I stole this from Corey Quinn, who loves AWS, and this applies to anything, but yeah, especially containers. It happens that there's not that many ways you can run Blender on AWS, but there are still quite a lot. And especially outside of, well, like I said, you can render Blender in a container. So there you go, 17 ways. Now, if that's not what you want to do, and you also don't want to use Lambda like I just described, there are 3 interesting ways to use it. So Amazon acquired a company called Nimble Studio, and what they do is, especially at the beginning of COVID, was super useful. You can say, create a virtual studio, and like spin up workstations and provision them with Blender or Maya or, I don't know, video games if you want. And here is my Active Directory, and boom, it generates a virtual studio for all your employees. You can say in which region you want it to be, and then it's extremely easy to set up. In just like a few hours, you have workstations in the cloud for all your employees, and they just like connect to it with a remote desktop client, and they can use it if they're close enough to the. Well, I tested actually. Our client is on the West Coast. I live in New York. We set it up on the West Coast, and it was like not as smooth, obviously, as using Blender on my machine, but still pretty nice, very fast. So quite impressive. ThinkBox Deadline is another company they acquired, and this one is really like, okay, let's say you're a VFX company, and you have to meet your deadline. So you've built your cool animation feature. You need to render all the frames. Let's just use all of the Amazon cloud and render the Blender jobs on that. And there's minimal work to actually make it happen, to configure the Blender copy of your graphics guy on his computer, make it offload all the renders to the cloud. So it's pretty neat. And finally, there's AWS Batch. It's another way they actually have a very good workshop right here. Self-guided workshops made by AWS are pretty cool, I find. So this one actually shows you how to set up AWS Batch for one-time render with a lot of capacity. So that's another option. So there you go. I don't know if you still have questions about how to render Blender in the cloud, or anything else.
You answered that one really well.
Yeah, I thought so. I was like, cool.
Are we on, guys?
Oh, I lost mine.
Check. Oh. Can you do reserved instances for GPU EC2 nodes?
Yeah, you can. So you get a small discount for that. That's
okay.
What I meant by. Oh, I cannot go back. Yeah, so you get a small discount. So it's worth it. Yeah. If it's worth it, it's worth it.
Right.
There you go.
You still have a balance, though. Yeah.
So it sounds like the major differentiator is just like how big your videos are, because Lambda on CPU can't handle.
It can't handle much. Yeah, no, it's really like for a niche use case like ours, it really makes sense and it's very easy. You can always imagine like if you have a frame, like an animation with 1,000 frames, you could say, cool, let's split it down and have one Lambda render each frame. But it's likely that even if you're rendering a commercial, 15 minutes is probably not going to be enough for one frame. So then you can say, okay, let's break it down into 100 different tiles. And so let's have 100,000 invocations of Lambdas to render my animation. It starts being a bit silly very fast.
All right, cool. Thank you, JR. Can we get a big round of applause? Yeah, just keep it on.